So the flow on this thing seems to be way off. I don't know. I doubt it's just because these are backwards. This is supposed to be going in, which is actually coming out, going to the tank, and then this is where the coolant's coming from. So I'm going to try to swap those next, but first I'm going to test the voltage at the connector below and verify that it's getting the voltage it should be. That way I know the pump is getting the power to actually run at its fullest. Then we'll drain the system. We'll go ahead and swap these fittings, and then we'll fill it up. Go ahead and test it again and see what it's flowing at. After that, I'll go ahead and pull this pump out, and then we'll put the OEM pump back in and test it again. This might be a little easier here. That's all it was. I got the connector pulled down here so it's a little bit more accessible. So I got the battery hooked up. I have the relay jumped with my harness, so there's power hook going to this connector. According to this connector end view, it's 1 through 5. 1 is hot, 4 being ground, 5 being another hot. So what I'll do is I'll go ahead and run this number 1 power. First I'll go ahead and touch the ground. Running 13.6-ish. Now we'll check. Yep, this is getting the same power right there. We've now verified that the pump's getting full power by jumping the relay and then testing it down at the connector. Next thing, I'm going to go ahead and get this Pureberg pump off and then get the OEM unit back on and test it, see how it does. If you have an OEM heat exchanger, you'll have a port right here to empty this out. I didn't, so as you can see, I just pulled this bottom hose right here. I got this adapter. I got this male-by-male fitting with a cap on it. I plugged that with a cap on it. Drained everything out of the system I could get. You can see the reservoir is empty. I pulled the cap on that. Just got to pull this 2 hoses off with the clamps, and there is one 10mm bolt down there. There should be another one. I'm gonna have to order one of those or just get it at the hardware store, but for the time being, one will hold it in place and I can see if there's any difference in the flow. This is the Pierberg 100-3 pump on the right. It takes its own little harness to connect to the factory connector. On the left is the OEM pump. Now, because this OEM pump is a little bit bigger, I was unable to get it to slide down here through the top. So what I'm going to do is mount them in the wheel well in an accessible location, and I'll make it easier for testing purposes. Next thing, this is the harness, jumper harness running to the Pierberg pump. So I'm trying to find another one of these connectors so I can make my own little harness. This little extension for the stock pump, but these things seem to be impossible to locate. But anyways, you can see this only has 2 pins. So it has the number 1 pin connected, and then it has the number 4 pin for the ground. You can see ground coming off there into the hot. So what I'm going to do is plug this in, and I'll go ahead and test and verify voltage at the end here. Let's see. We have ground, hot. There we go. 13.9. Now, before I move any forward with testing the pump itself, again, I'm going to run it just into this wheel well. I think I can get enough play out of the hoses to run them down there, and it won't be the exact configuration it will be running when the car is actually driving, but it'll at least allow me to test the pump without having to squeeze it back in where it came from. I'm going to plumb in a T right here. Since I don't have any way to drain this, I'm going to have a T come right off of this with the ball valve. Then I can stick a piece of hose on there for draining this whole system. And then this has a nice 90 on there. Again, this is just going to be for testing. I can swivel it over, plug it onto the other side of the T, and it should still function pretty much like normal. So I'm going to do real quick, so I'll measure this. It's 1 3/16, so it'll be about right there. So slam this on. I'm gonna go ahead and try to mount it up in here temporarily. That way it'll be way easier to access. I wonder. Things don't always want to. pump it on a little bit, and we'll have to fill this back up in a minute. Pop this thing on, just have it ready to go. Okay, so we're at 0.15. Now we'll jump it one more time and see. I could tell when I opened that valve, pushed a good amount of fluid through, so that should be bled. I decided to test the PureBird pump again in the new location to see if anything had changed. It's still flowing about the same amount, so next I'll go ahead and get the OEM pump in there and go in and test the flow and see what it looks like. My camera died, but I got the OEM pump swapped back in. All I had to do was empty out the system with this ball valve. Just stuck that right into the jug, opened it up, drained out most of the system. For this OEM pump, I just had to add this little length of hose. It's 3/4 inch hose. The reservoir hose had enough slack to plug right into the pump. I got the connector hooked up. It's got a little bit of slack on the wire, so that's good. I hooked the factory hose up to this little length with a 3/4 by 3/4 male by male barb fitting. Just threw a couple hose clamps on there, made it pretty easy. So now this thing's all plumbed in, pretty much same as the PureBird, and we'll go ahead and get some fluid in it and test this one out, see how it does. So this one only seems to be pumping 0.14, 0.15, 0.14. So that other pump definitely was pushing more fluid, had more flow on it. It's tuned up from 0.18 down to 0.14 now. I've now bled off that T to make sure there's no air pocket in there. You can see the flow is just about the same as it was before. Now with this flow meter, if you hold this calibrate button down, a number will come up flashing, and I believe that's the conversion factor. That's telling it how many times, how much flow is going through that based off of how fast the turbine inside of this flow meter is spinning. Mine came programmed at 0.05. Now talking to my buddy Gabe Griffin, his came calibrated at 1.00. So that tells me that the flow rate I'm showing is actually only 5% of the real flow rate going on. Because if I change this up to 2.05 and run the system, you'll see that it shows a much higher flow rate. You can see that it's showing a flow rate much more than before. So you can tell that by changing this conversion factor, or I've seen it referred to as the K factor, it will skew the readings on this meter. I'll go ahead and change this to 1.00, which I believe is what it should be set at, and we'll go ahead and test it, try it again, and see what it looks like. Now there could also be some kind of blockage in the system itself. What I would like to do is go ahead and bypass the main heat exchanger as well as the supercharger and just test the pump going to the small heat exchanger and then back up to the reservoir and see what kind of flow number that's going to give us, and we can see how much of a restriction the rest of the system is. I'll go ahead and get some new hoses ran from the small heat exchanger up to the reservoir and we can keep pretty much everything else in place.
Reservoir. This will give it a place for air to get in the system and push that fluid out. I turn this valve. There it goes. Go ahead and get this thing off. Any excess fluid. So, run this like that. Set it. Go ahead and do this. Maybe a little bit, but it'll be alright. So this will go on there pretty good. Now, this whole system, all it is, it's coming down out the reservoir, goes into the pump, pump's sucking it into the auxiliary radiator, goes through, it's coming out over here, snaking right back into the reservoir. So now, we'll be able to check the resistance. Plumb this thing back on there. That way I still have a way to drain the system. I'm not going to make a giant mess. This 5/8 hose really isn't going to want to go on here.
Now this is testing it with the same conversion factor of 0.05, just so I had a good idea of the differences that we've already tested. It's showing about 2.6 gallons per minute, which is almost double before.
Okay, so I basically hooked it all back the way I had it. Just running the whole system, going through both heat exchangers as well as the supercharger and the reservoir coming back to the pump. Now that I've changed the calibration factor, you can see it's showing a flow rate of 2.63, 2.57 gallons per minute. That was changing what's, I believe it's known as the K factor, or just the conversion factor for how many times that turbine in there spins, how many gallons of fluid is actually going through it. So I bumped it up to 1, which was the same as my buddy Gabe, and now it seems to be flowing around what it should be. So his K factor was 1.00, mine was set at 0.05, which I believe meant I was only reading 5% of the flow. Now that I bumped it to 1, it's looking at a little bit of over 2.5 gallons, and this is on the stock pump. Basically all the stock lines except for a couple little pieces of 3/4 to get this all plumbed in. Alright, now it seems we've got that figured out. I can go ahead and put that Pureberg pump back on down there, swap this one out, and check to see what the flow reading will be then. I have a baseline number with the OEM pump and pretty much the factory line setup, and now I'll be able to compare as we make changes to the new pump to the bigger lines and see exactly what happens.
I've swapped the Pureberg 100-3 pump back in. This is the new flow rating, about 2.9 to 3.1. This concludes the testing and the troubleshooting I'm doing for now. Next, I'll be getting the blower taken off and we'll work on getting the motor out. Thanks, everybody.